Hello everyone, and welcome back to another edition of Try Science. Last episode was delicious. Remember, it was all about food science. Well, hopefully you remembered some of what we learned last time, because it will play a part in today's episode. Well, what is today's episode about, you ask? Well, let's see. Did you see all those colorful rocks with different shapes and sizes at the top of our show? You might have even seen the word rock somewhere. So being the little scientist that you are, what do you call the study of rocks? Exactly. Today, we will be talking about geology, which is an earth science that includes solid earth, the rocks which make it up, and the process by which they change. Our friend Megan at the Delaware Children's Museum has a special day planned for all her little geologists in training. So stay tuned as we start this episode of Try Science.
Hi guys! I heard you were checking out Bank on It, huh? Is that the money place?
I see rocks.
Uh-huh. This is all about rocks. So anywhere around the room, there's stuff to check out. That's okay. So that is behind him there. That is a cave. And you can crawl in there, and there are 8 rocks hidden in that cave that you get to find. And once you find them, you bring them out, we look at them, then you hide them for the next people that come in. So where do you want to? Yeah, you can go right. You can be the first people in there. All right, and now it's on the lowest setting. See how these lenses are different lengths? So right now, it's on the lowest magnification, but you're gonna look in, and does it look fuzzy? Okay, so what we're gonna use to adjust it is this knob right over here. See how that turns? Now some of those lines, go ahead and look in. A lot of those lines you can see are actually, those should be part of the rock. So see how it's kind of yellowish in there, but when you look at the rock itself, it looks like what color? Yeah, and so it's so thin that the light is shining through it. All right, let's try this one. Put that underneath. And does that look like is it made up of flat slices like the one we just looked at, or is it made up more of cubes? Yeah, so rocks are made in different ways, and when you break them, they break in different ways. We actually have a room next door where you're gonna get to hit a rock with a big hammer and break off a piece. Isn't that neat? All right, so leave that one there. If anybody else comes in, it'll be all adjusted.
You just saw some brave and bold children enter a dark cave to look for rocks. Do you know what we call that, boys and girls? It's a silly name when you hear it. We call exploring wild cave systems spelunking. Many geologists go spelunking to find all kinds of rock formations. If you ever saw Abe Lincoln's face on Mount Rushmore, the Grand Canyon, or an awesome ancient pyramid, you would probably say, wow. However, a geologist sees granite, volcanic rock, limestone, and the earth over millions of years. In other words, rocks. Well, you can't throw a rock without hitting another rock. They're everywhere. Rock creates and shapes the Earth's landscape. It forms our magnificent mountains, shapes the deepest oceans, and safely separates us from the boiling magma beneath our feet. Okay, technically, magma is uber hot liquid rock, but you don't want to stand on it. Stay tuned to learn how you can create your very own Earth with all its different layers, including magma.
All right, guys, shoes on and grab a cushion. So what are we going to learn about today? What clues did you see? You said there are lots and lots of rocks around here. And so a scientist who studies rocks and the Earth is called a geologist, because geo means Earth. So we are actually going to make models of the Earth out of Play-Doh, which should be pretty fun. But I've got some rock questions for you. Have you ever come home with rocks in your pocket? Have you ever learned how to skip a stone on the water? Have you ever played rock, paper, scissors before? So rocks are everywhere. They're under our feet. They're used to build lots and lots of stuff. So there's lots of things to study. So I have a question. What are some things that we make out of rocks? A path or a road, okay? Pyramids. The pyramids are made out of a rock called limestone. Oh, that's right. There they are in the background. All right, last one. What was the rock used for? Actually, we got some on both pages. Houses. And what part of the houses? The roofs. And how about this? What do you think this might have been? A hammer. Yep. So rocks have been used for all different kinds of things. All right, what have I got here?
A ball.
A ball, and what's special about this ball? It's the Earth.
And there's the sun.
Yeah, this is DCM, it's our model of the Earth. What shape is our Earth? Okay, so a circle. Yeah, a circle is a flat shape. Our Earth is a sphere. So when we make our Earth model out of PlayDoh, we are going to need to make it a sphere. So what do you think? If we could get down to the very, very center of the Earth, would it be hot down there or cold? Really, really hot. In fact, the center of the Earth is as hot as the sun. So do you think scientists can travel down there? No, oh, you get burned up. So they have to study it other ways with different energy waves, like when earthquakes happen. They can tell a little bit about what the center of the Earth is like. So what's a hot color? What's a color that we could use of PlayDoh? Red. Yeah, so we're gonna start with, actually we're gonna use all of those colors, but we're gonna start with red. So everybody needs, and I will get for you, a tray, and this is what you're gonna build on. All right, and now you're gonna need a measuring tool. So first we're going to give you a ruler, and then I'm going to grab my toothpicks, and everybody's going to need a rolling pin because some of your Earths are going to need to be rolled flat. Okay, so everybody's going to need a toothpick. For what? Well, that's going to help us measure how thick our Earth is. And we're going to pretend that our toothpick is a little ruler. And so what you're going to do, we're going to find the really small numbers, the centimeters on here, and line up your, yep. And so you're going to make a mark. Your toothpick is how many centimeters long? It goes up to what number? 6. So after every centimeter, you're going to make a little line with the pen on your toothpick. Does that make sense? All right, and so you've got your little lines, right? So now you need your PlayDoh. Okay, so you're gonna reach in. I know, lots of red PlayDoh. So just a little handful and roll it into a ball.
Hey, Simone, can you give some to me?
There you go. So just about this much. So when we measure, when you roll it into a ball, you're going to use your toothpick. So our center of the Earth only should be about 1 centimeter tall. So that means your center of the Earth should only be about this thick. So it's not going to be as big. It's going to be sort of small. And then we're going to add more layers to it. So put your ball down here. And then you're going to push it all the way through, and it should only come up to your first line. If it's taller than that, you got to get rid of some of your red dough. So this is our core of the Earth, like an apple core, and it's so hot. But you can imagine the Earth is really big, so all these other layers of the Earth are pushing down on this. So this is really hot, but it's still solid because There's so much pressure. All right, I'm gonna measure my center again, and it should only come up to the first line. That one's yours? Okay, so mine's pretty good. It only hits my first line. So next we're gonna do orange. This is your inner core. Now we need your outer core. This is also really, really hot, except this layer in the real Earth is liquid. We don't have any liquid Play-Doh. So how do you think we're gonna get this layer around our ball? You could put it flat and then cover it. So when you roll your orange around your red, you should fit it up. It should fit 3 lines, 3 centimeters. All right, so come get your orange. Take your orange, take an orange clump.
Okay.
And make it flat. You need a bit more than that. You're gonna make it flat and then wrap your red one inside it. Put mine right in the middle and wrap it up and roll it together. So I won't be able to see my inner core anymore. It'll be all rolled up in my outer core. Put your inner core inside and wrap your outer core around it. All right, is that about half your toothpick, do you think? Yeah. So now we have 2 layers. All right, here we go. This is our thickest layer. This is gonna fill up the rest of our toothpick. All right, friends, we all need yellow. So grab some yellow and you're gonna make it nice and flat again, just like you did with the orange. Remember, this layer's gotta be really thick. It's gotta fit your whole toothpick in there. So you're gonna flatten it out.
Like a bigger pizza pie.
Yeah. And you're gonna plop your inner and outer core right in the middle.
Make it flat. Make it flat.
And roll it up. I'm gonna roll mine around on the floor to make sure it's all nice and round. And then I'm gonna check with the toothpick.
I don't need this much.
I would say you need a bit more because I can still see some orange.
Yeah, I know.
Oh, look at this. I need just a tiny bit more yellow because my toothpick is still sticking out just a little bit. This core is, or this mantle of our Earth is very thick.
Do you want to give it to Grandma?
That's very hot.
Yeah, we're still very, very hot. Do you think that people could get down to this layer of the Earth maybe?
No.
No, still too hot. Yeah, all right. So wrap and roll. You guys ready for your blue and your green? So here you just need a very, very thin layer. If we were gonna measure it on the ruler, it would be only 1 millimeter, one tiny little line thick. But that's so small that it's hard for us to measure. So when I did my blue, I just flattened it out really, really thin. And I did a little bit of blue and a little bit of greens. So I just did sort of a patchwork. I did a little bit of green and a little bit of blue. Now we want to be able to see inside our Earth when you're all done. So how could we do that? I could cut it in half. And so we're going to use some fishing line. So we're really, really, really like a thin, thin wire. All right, ready to have yours cut in half? Okay, so can you take this side? We're going to run it right down the middle and then go straight down.
There you go.
Pull, 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 pull.
There's some green ones out right here too.
Okay.
Kind of look like
Oh man, that's a good looking world.
There you go. All right, so you're gonna pick which one you want to take home. Okay, and so now you're gonna start labeling. And what we're gonna do is we're gonna use our toothpicks and you're gonna have little signs for each layer of the Earth. So you did inner core, outer core, mantle, and crust.
So clever the way Megan had her little geologist make a representation of the Earth's layers. So you see, science can be informative, but it can also be really fun. Now here are some things you may not know about rocks. Granite, limestone, marble, and sandstone are examples of kinds of rock. Geologists divide rock into 3 large groups: igneous, metamorphic, and sedimentary. Lava or magma form igneous rock, and then changes in pressure or heat create metamorphic rock, and water and wind create sedimentary rock. Each rock group includes hundreds of different kinds of rocks. Like the world's oldest blog, rock reveals millions of years of events and change. It shares how and when the Earth's features, like mountains, oceans, or canyons, were shaped. In a way, embedded fossils provide a selfie or a picture of the environment at the time the rock was formed.
All right, so you're gonna reach in the box. It's full of rocks. So you're gonna reach in, pick out a rock, and this is gonna be your rock to learn about. So put your hand in.
Just one.
There you go. Does it have a number on it? What number does that say? 3. All right, so I'm gonna give you guys a pencil and a paper, and then each of these tables around here is a station that you can use to learn more about your rock. And if you want to start at the color table, that's over there, so you get to draw a picture of your rock and color it in.
In this station, you must put your rock on one side of the scale and add pennies to the other. Your goal is to see how many pennies it takes to balance out the scale. In the second geological station, the kids play a board game where they have to match the rock in the bin with the picture it best represents on the card in front of them. It's sort of like bingo, only they are learning about all types of rocks, like sodalite and rhodonite. The third station might be familiar to our viewers. Our little geologists have to determine whether a rock will float or sink when dropped into a cup of water. In case you forgot why they might do one or the other, let's take a look back at our last episode on food science. You might be wondering why your marshmallow floats. This is due to tiny air bubbles. These little air bubbles make the marshmallow less dense, causing it to float. Think of it like a submarine. If it has a lot of air, it floats. If it has no air, it sinks to the bottom of the ocean. Wow, it's amazing how simple it is. And the same principle applies to rocks. Let's head over to the station to see the results. One characteristic of a rock can be determined with a streak test. It involves scraping a rock on a piece of unglazed porcelain. The rock leaves behind a trail revealing its natural color. Let's see how the class made out.
I'm gonna go get a big hammer for us to use, and we get to pound on the rocks and break off a piece.
It's clobberin time! But first, let's talk about safety. Can you guess what you should wear over your eyes for safety? Is it A, sunglasses, B, goggles, C, reading glasses, or D, a welding mask? Well, if you guessed B, then you are correct. It is important to wear safety goggles in order to protect your eyes and assure you are A-OK. Check it out.
you're trying to hold the rock down with the hammer. So you pound like that. Now I want you to give this one a big whack.
My personal favorite station was the Rock Bingo, again proving science can be fun as well as informative. I'm sure a lot of you enjoyed smashing the rocks. Well, did you know that most rock is a mixture of minerals and bits of other rock, and that there are more than 4,000 different minerals in the world? And though most minerals form small particles, some form large, beautiful crystals like diamonds and rubies. Rocks can form many things over time. One of my favorite things is when hot molten rock escapes from the Earth's surface and cools, forming, can you guess? A volcano! That's right. You are all so far ahead of me, I guess you've been doing your homework or watching Try Science. I prefer the latter. So let's not waste any more time and join Megan for her final experiment using a volcano.
I've got 2 ingredients that are going to make our volcano erupt. Baking soda and vinegar, you got it. Okay, so that's where we're going to put the baking soda. So everybody can do, we'll start with 2 scoops of baking soda. So Saul, why don't you, I'm going to hold it over here. I'm going to do a big scoop, put it right in the top. Okay, and do another scoop. Okay.
Good job, buddy.
So you guys are putting in the baking soda, which is a base. We're going to add an acid, which is the vinegar. I promise it's not going to come out of this box. It's not going to shoot up in the air. It's going to come out of the top of the volcano and down the sides. So even though we're learning about geology, right now we're doing a little bit of chemistry. We're mixing. All right. So when we mix the baking soda and the vinegar, one of the things it lets off is a gas called carbon dioxide, sort of the same stuff that's in soda that makes it all bubbly.
Does it sound like soda when you shake the soda?
So notice how the way the volcano was made, it has this channel and these big sides here, so the water, or the liquid, sorry, not the water, the liquid wants to follow these channels, just like real liquid. But eventually, rivers and volcanic lava, they might even carve new pathways in the volcano. Now, eventually, our reaction is going to be all over. So all of our baking soda and our vinegar will have mixed. So at that point, I'll know when I pour more vinegar in, no more bubbles will happen. But because it's still going, I know that we still have some baking soda in there that can be mixed with the vinegar. If I had a giant balloon and I could put it over the top of a volcano, what would happen? Yeah, it would start to inflate because of the gas that's coming out because of this reaction. Okay, I'm going to do it one more time.
Oh my goodness. Take it back from something like that, like a roll back, vinegar, baking soda.
Alrighty, guys. That is all we have for today. Thank you for hanging out with me. You are welcome.
Well, there you have it, boys and girls. Another fun-filled, scientific, terrific time right here on Try Science. As always, a big thanks to Miss Megan at the Delaware Children's Museum for all her help and scientific information. Remember, if you would like to be a part of all of this excitement, you can come on down to the Delaware Children's Museum the second weekend of every month from 11 to 12 p.m. or from 1 to 2 p.m. and maybe we will see you on the next episode of Try Science. I will leave you with a quote from Albert Einstein, who said, "Most people say that it is the intellect which makes a great scientist. They are wrong. It is character." Have a great day.